Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, we're going to look at how you can prove that the mean of a random variable with the following probability density here is given by this one, by this term. You can see at one glance that, wow, this doesn't look anything familiar to you, but that is because the probability density here uses different Greek alphabets, but it is actually similar to what you have seen in the previous video when you talk about the probability density function for beta random variable. So remember what we have seen before. Here we've got a probability density that depends on alpha and beta, and it looks like this: alpha plus beta. Over here we got gamma alpha, gamma beta, y, no y, so previously it was x, yeah, it was x, alpha minus 1, 1 minus x, beta minus 1. So that is the probability density for beta distribution, which I hope looks familiar to you guys. Okay, now what I have shown you here is actually similar to what is given in this question right here, except that different alphabets are used. For example, this part here, instead of using alpha, it is replaced with psi. Instead of beta, we have omega over here. Okay, instead of x, we have y as a random variable. It doesn't matter. What is important is that you are able to recognize that this probability density function is related to the beta distribution. So you are good to go after that. Okay, now we know that in order to find the mean of a random variable, we got to start with a very basic idea, which is finding what is expected value of y. And in this case, it's going to be, you're going to integrate y. Then here we've got fy. So this is fy. We're just going to write the probability density function. Psi plus omega. So here we've got psi. Here is omega. This is y minus 1. 1 minus y. Omega minus 1. So here is dy from 0 until 1. Okay, right, let me just box it up. Okay, now what are we going to do is, I hope you can recognize that this part here is constant, and so you can take it out from the process. So what we have next is this is equal to psi plus omega. Okay, so we take it out, and then what we're going to do next is we're going to combine y and y together, and we're going to write down in terms of, we're going to write it down like this. Okay, let me just show you how we can write it down. We can write down as y 1 plus psi minus 1. Okay, it is the same thing really. You're just combining, this is y to the power of 1. So here we can write down in this manner. Okay, and then here we have 1 minus y, omega minus 1 dy. Now there is a reason why I would like to write it in terms of something minus 1. Okay, so my aim, my objective, my aim is to be able to write in terms of something minus 1. Now why is that so? Well, that is so because I want to be able to apply the beta function, the result of beta function. What is beta function? Let me just rewrite the result of beta function? Well, if you have this integral x alpha minus 1, 1 minus x beta minus 1, the result is equal to this guy here. So this is the result. So this is beta function. And if you are able to manipulate this situation, this information, therefore we don't need to integrate this process. Instead, we just apply the result straight away, okay? And notice the similarity between this part here with beta function. Well, of course, we have y, here we got x, but doesn't matter because the result here depends on the alpha and beta. So the result here applies alpha and beta right here. So we have alpha minus 1, but at this position we have something minus 1. At this position we have beta minus 1, and at this position we have omega minus 1. And we are just going to replace this guy at the alpha position. So we can just use the result here and replace this one here at alpha position, because here we have something minus 1. So here alpha minus 1. So we can say that this can be replaced at alpha. So it can be replaced all at alpha position. And omega can be replaced at beta position. So without having to resort to integrating this function, we are able to write the result straight away. So how does the result look like? So here we have this one here, psi plus omega over. So the result for that one is going to look like this. We're going to multiply that with this one here is at the alpha position. So we have gamma function for this one, which is this guy, 1 plus psi. So here will be replaced at beta. So here we got beta. And here we will have this guy plus this guy, which is 1 plus psi plus omega. Okay, that looks simple. Okay, it looks simple. We don't have to do integration. Now we just need to simplify this part. Okay, now we're going to simplify that further. I'm just going to use this page. Let me just write down what we have so far. So here we got okay, so that one is, okay, let me just rewrite that again. Expected value of y is equal to okay, so this is the result multiplied with, oops, sorry, this guy, 1 plus psi then we have omega. At the bottom here we have 1 plus psi plus omega. Okay, so that's the result that we got. Now in order to simplify that further, we need the properties of gamma function. Okay, so for example, this one right here can be simplified to be well, you can write this in terms of gamma plus 1, which is equal to this result here. Now if you don't remember what is this all about, you have to go back to my video related to gamma distribution, where I've talked about the gamma function. So in gamma function, if you have gamma alpha plus 1, that's the same thing as having alpha gamma alpha. So here 1 plus psi, we can rewrite that as psi plus 1. And the result here is going to be psi gamma psi. Okay, so go back to this video related to gamma distribution if you want to find out more about this. Okay, right, just going to write down the result now. So okay, now this part here becomes psi gamma psi omega. And this part, okay, now what happens to this one? Again, we are going to use the idea from the property of gamma function. So this one here, this is the same thing as psi plus omega plus 1. So this is something, so it will look like something plus 1. So alpha plus 1, the result is alpha gamma alpha. So if you have something plus 1, the result is going to be something gamma something. Yeah, so that's the idea. So that's what I'm going to write down. Next is something, which is psi plus omega gamma function psi plus omega. And by doing that, you can cancel out happily. You can happily cancel this out, I hope. There you go. There you go. And so you are left with this result, which is psi over psi plus omega, which is what we are supposed to show right here. Okay, so there you go, related to the first one, which is to prove that the mean of a random variable is given as such. Now we're going to move on to the next part, which is to prove that the variance of y, of the random variable y, is given by this term right here, okay? Right, now we are going to start off with the usual stuff, which is what is a variance of y? Variance of y is just expected value of y squared minus expected value of y, and you square it. And this part has already done just now, so we're not going to focus on finding the expected value of y squared. Okay, right, now so what we're going to do next is we're going to find what is expected value of y squared, and it is given by this process. We have y squared, and then we have this long density function, which is psi plus omega, psi and omega. Whew. This is just a long process. You just have to be patient about it, okay? Y and then psi minus 1, 1 minus y, omega minus 1 with respect to dy from 0 to 1. And again, you can see that this is the constant. This part here is a constant. You can take it out from the process. So what we have then is gamma function psi plus omega. This one is this guy right here. Next is 1 and 0, and again I'm just going to combine this value here, y with y, and I'm just going to try and write y in terms of something minus 1. Okay, I just want to write it in terms of that because I want to be able to use beta function. I'm going to be able to apply the result here directly. So I want to be able to write the exponent here in terms of something minus 1, so that it looks similar to alpha minus 1 that is given by this idea of beta function. Okay, So that is my objective, that is my aim. Well, therefore, y is going to be written as psi plus 2 minus 1. Okay, so I've combined the y's in this position and this position, so it becomes psi plus 2 minus 1. And here we've got 1 minus y, omega minus 1 dy. And again, I say this part here can be solved directly using the idea of beta function. And the idea of beta function is that the result of this integral is going to be equal to alpha beta, and then here we've got alpha plus beta. So this is the result of beta function. Yeah, and we're just going to apply what is alpha and what is beta accordingly. Okay, therefore this part here, you can see clearly that this is like alpha something minus 1, and this will replace the position of beta in this result here. Okay, so I'm going to write the result now. So here we have gamma function of psi plus omega, gamma function of psi, here we've got this, and then for that part here we will have gamma, here is alpha, so we have psi plus 2, and then we have gamma omega, and then at the bottom you will add these two items here, so we have psi plus 2 plus omega. So this is the result from the idea of beta function. You just apply it right here without having to go to the process of integrating this function. Pretty simple, isn't it? Now what we're going to do is we need to simplify the expression here, and we need the property of gamma function, because what we have right now is just gamma function, and we need to be able to simplify that. Okay, well, let me just go to the next page, and I'm going to just rewrite what we have so far. Here we've got, therefore, expected value of y squared is, I'm writing down the result again. Okay, and for this part here we have psi plus 2, sorry, omega, and then here we've got omega. At the bottom we have psi plus 2 plus omega. Okay, now this part here can be simplified. We can write down in terms of remember the property of gamma function, where you have gamma alpha plus n. So when you have gamma alpha plus n, therefore you can write down in terms of alpha times alpha plus 1, blah blah blah, until alpha plus n minus 1 gamma alpha. Well, again, if you are not sure what is it that I'm talking about, well, you have to go back to my video related to gamma distribution, where I have discussed the idea of a gamma function. So you need to be able to be comfortable with manipulating all those properties in order to come up with this, in order to solve this problem. Okay, so therefore if we have like gamma alpha plus 2, so if you have psi plus 2 in this case, this is the same thing as having psi times with psi plus 1, and then gamma function of psi. So that's the result. Okay, where do I get this result from this property? Now where does this property come from the idea of gamma function in that video of gamma distribution. So go back and check it out. Okay, now how about this one? How can you simplify that further? So for that one here, we have something that can be written as psi plus omega plus 2. I hope you can see that this looks like gamma function of something plus 2. Now if you have psi plus 2, the result is psi times psi plus 1 times gamma function and psi. So if you have psi plus omega, you have something that looks like this. Therefore, we're going to have the result equals to psi plus omega times psi plus omega plus 1 times with gamma function psi plus omega. So you see it follows the pattern. So this is psi plus 2, so we have psi plus 1. And if you have psi plus omega, so at this position here we will have psi plus omega, and then psi plus omega plus 1, and this gamma function of psi plus omega. Again, if you really want to be comfortable with all this, you need to go back and watch the gamma distribution, okay? So I'm just going to write the results here. So what we have is, well, we have this guy plus omega. Okay, and at the top part here, this is the result. So I'm writing it down. Plus 1. This one is the result here, omega. At the bottom here, the result is as such. Okay. Oops. Okay. Where you can see that by doing that, we can happily cancel the terms out. For example, this gamma function here can be cancelled out with this gamma function. Next, gamma function for this one will be cancelled out with this one. This one here will be cancelled out with this one. So we don't have gamma function anymore, and we're just left with some values of psi and omega. Okay, therefore final result is psi times with psi plus 1. Okay, so that's the result. Next, at the bottom we have psi plus omega, psi plus omega plus 1. So that is expected value of y squared, and we are not done yet because we need to find the variance of that. Okay, so what's the variance? Well, variance of y is going to be this guy. This is ey squared. So I'm just going to rewrite the result here. If you want, you can multiply this, so we get psi squared plus psi. That's at the top part. At the bottom, I'm just going to leave it like that. Plus omega, psi plus omega plus 1. So that is ey squared, and we're going to minus ey and you square it, right? So what is ey? Ey is this one, psi over psi plus omega. So here we have psi over psi plus omega, and you got to square it. Okay, so that becomes psi squared plus psi over this one plus omega, and this becomes, if you square it, you get the result here, psi squared. And at the bottom, I'm just going to write down in terms of this psi plus omega, and you square it. Okay, now clearly, well, I'm just going to continue right next here. Okay, so now next is we're just going to need to find the common denominator for the bottom part. So here we got psi plus omega squared, here we got psi plus omega plus 1. So the common denominator is going to look like this. Psi plus omega, you square it, and then psi plus omega plus 1. So that's the common denominator. Therefore, we need to focus on the upper part. So here we've got this guy will be multiplied with psi plus omega, yeah? So we have squared plus psi squared plus psi will be multiplied with psi plus omega. Okay, I hope you can see that by doing that process, if you cancel out this term with this term at the bottom, you have this guy with this guy and this guy. So that guy with this guy and this guy, you get back the original stuff here. Okay. Okay, next for this one here, that will be multiplied with, oops, sorry. For this guy here, we will have negative psi squared, and this thing will be multiplied with this. So we have psi plus omega plus 1. Yes. And I hope when you see that, you can see if you just focus on this part here, if you cancel out this guy and this guy, this will be equal to psi squared over psi plus omega squared, which is this one, yeah? Right, just checking whether what you're doing is correct, really. Okay. Okay. Now we are good to go. Plus, you will see that the bottom part here has already resembled what we are supposed to prove. You can see that this is the result here that we are supposed to get. So this is the bottom part here. We just need to make sure that we get this right, the top part, okay? So the bottom part is already okay. It looks okay to us right now. So the bottom part is all right. Now we just need to simplify the top part of it, okay? So that's what we're going to do. So psi squared multiply with psi, you get psi cube. Psi squared with omega, psi squared omega. Psi with psi, we get psi squared. Psi with omega, psi omega. Okay, next, minus. This one is psi squared omega. This one is negative, sorry. Sorry. So that one is psi squared, and psi is psi cube. Psi squared and omega is psi squared omega. Psi squared with 1 is going to be, this is correct. This one is positive. So psi squared times 1 is going to be negative psi squared, yeah? And at the bottom part is psi plus omega squared, psi plus omega plus 1. And I hope you can see some terms can be cancelled out, such as this one with this guy with this guy, and y squared omega with y squared omega. So you get the top part as psi times omega, or omega times psi, doesn't matter, but well, we got the top part right, and that's it. We have managed to prove that the variance is given by this term right here, okay? So that's it. So that's the result, and we're done. Thank you very much for watching. Okay, have a nice day. Bye.